Hello everybody, I will start my today another live coding session. So today I start the question, binary tree right side view. Given the root of the binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. Okay, so let me start with the clarification. So in this question, I'm given the root node, which is the tree node class, and I will return the number array. So this is the list of the values on the right hand side at each level. Okay, and as the constraint, I would like to confirm how many nodes there are. Is it possible that the tree can be empty or it has at least one node? Something like that. So when I take a look at this, I can find that there is at least, no, the tree can be empty. So this tree node given can be null. So now let me look at some examples. So as the edge case, if the given root is none, I should return an empty array because there isn't any node. And let's say the tree looks like this. In that case, I take a look at this, level 1, and I find 1, level 2, and node 3, and level 3, node 4. So I will return 1, 3, and then 4. Okay. So this is it. Good. And for the algorithm, I can use the level order traversal, which means that I can use the breadth first search. So yeah, here I take a look at level 1 and then I find 1, and level 2 and then find 3, level 3 and find level node 4, as I said. So the time complexity can be O of n because I have to traverse each node once. And in the worst case, if the node looks like the linked list, like 1, 2, 3, every node is on the right, and every node is the right child of another node. Yeah. In that case, I have to traverse all the nodes, definitely. So the time complexity can't be better than this. And for space complexity, it should be constant because aside from the returned list, I don't use any non-constant data structure. Okay, so that being said, let me get started with the implementation. So this is the edge case. Yeah. From here, I do the BFS. And I have to make sure that I distinguish each level. I do this. So here, I start a new level. And I push the child node. So if child is not known, I append this to Q. Okay, so for now, let me focus on writing the code for BFS, and I will amend it later. Okay, so basically this is BFS, level by level. So what I have to do next is to append the rightmost value in each level to the returned array. The firstly, I append root dot bar to the returned list. And in line 45, out is popped out. I don't have to append this because out is already, yeah, you know, root value is already appended. But for child, I have to append it. But this is the case if this is the rightmost child. So my idea is instead of visiting left to right in BFS, I will visit right to left. In that way, I can immediately know if it is the first node or not. So here, I do right and left. And I will define first node is none. And here, if first is node none, I update this with the child. Okay. And here, first node, if this is none, I append this to the returned list. Let me name it to rightmost node. The reason why I have to do this is, in my approach, I take a look at the value of the node before pushing that node into the queue, which means that in the last level, in the lowest level, queue can be empty. No, I mean, let's say I have something like this. In this case, after taking a look at this level, queue has node 2 and 3. But from here, I can't find any child from node 2 or node 3. So what happens is that I do the final loop from line 46 to 59, but I don't find any child, which is not known. So I need this check to avoid that known to be appended. Okay, so that being said, let me quickly run my code. So in the case, okay, I will start with the edge case. If the given root is known, I return the empty array. Yes. So I pass this. And I will take a look at one more example. So let's say tree looks like this. In this case, I expect that 1 for 3 should be returned. Okay, so I will take a look. So Q first 3 should have the root node 1, and read should have this one. So for this is okay. And because there isn't anything in the queue, node 1, I go to line 55, and this is now known. And in line 56, length of the queue is 1, so I traverse only once, and I pop left node 1, and I take a look at right child and left child. Right child is 4, left child is 2. And when I take a look at right child 4, because child is not known, I go to line 62. Rightmost node is currently known, so it updated with this node 4. Okay. Then in line 64, I append this node to queue. Okay. And I come back to line 56 and I take a look at node 2 And what happens is that rightmost node is not updated, and I just append 2 to the queue. That's it. Okay. And after that, I go to line 66. Rightmost node is not none. So I append this. Oh, this should be this. And also I have to append the value. Okay. So now what is appended is the 4. No. Sorry. 4 2 should be appended here. Okay. That's it. So this is node and node. Okay, so it works in this way. So after that, I have 4 and 2, and 4 doesn't have any child, and actually this doesn't cause anything in line 56 to 64. And when I take a look at node 2, yep, I find the root child, which is 3. The 3 is appended to the root, and that 3 is appended to the queue. This is popped out, and then 3 is appended here. And now this is the next term. So in line 56, length of the queue is 1. So I take a look and read this node 1, sorry, node 3, actually. And out of right, out of left, both of them are none. So nothing happens in line 56, 59 to 64. And in line 66, rightmost node is none. So nothing is appended to the read. And that's it. I written 1 for 3. Like this. In line 52. Okay, so I passed this test case. So it looks fine. I covered those lines on my code, and also I covered the edge case and also the lowest level issue. So it looks pretty fine. Let me submit. So out is pop out. Let's see, pop left. Good. Accepted. Great. Okay, so let me quickly wrap up. So today I solved the question binary tree right side view. In this question, I'm giving a tree, the root of the tree, and my task is to do the rightmost node for each level. I mean, I return the list of the values of the rightmost nodes in each level. So in this question, I use the breadth first search to do the level of the traversal. And what I took care is, firstly, I did the traversal from right to left to find the rightmost node. I can find the rightmost node easily. And also, I had to take care that in my implementation of BFS, I take a look at the value of the node before pushing that node into the queue. So in the last level, in the lowest level, even though there is something in the queue, I don't find any more new level, lower level. So in that case, I shouldn't append any, value to the return list. So I covered that in line 66 and 67. Okay, that being said, I finished my test coding practice. Thank you so much. Bye.